So these are some questions related to example questions are there related to paper 2 and paper 1 MCQs. So which row in the table correctly lists the galaxy, a planet and a star? So Milky Way is a galaxy, Earth is a planet and Sun is a star. That's why B is the right answer. So in question 2, orbit around the sun of a comet is not circular. As we know, it's elliptical. The distance between the sun and the comet varies, as you can see. And as I mentioned, whenever a question is there about the comet, the center of the path should not, like, you should not make it at the center. So they're asking where in the orbit the speed of a comet is greatest. So how you identify when the comet is closer, the kinetic energy will be maximum. So at which position the kinetic energy will be maximum? At this position, the kinetic energy potential will be minimum and the kinetic maximum. So speed will be greatest speed at r. And which position it will have the smallest speed? When it is far, the potential energy will be maximum and the kinetic energy will be minimum. So comet will move at a slower speed. That's why C will be the, not C, D will be the right answer. So R and P. So in question 3, orbit around the sun of a particular asteroid or dwarf planet is not circular. The distance between the sun and the asteroid varies, as you can see. The asteroid possesses both gravitational potential energy and the kinetic energy, which energy transfer take place as the asteroid move from X to Y and then from Y to Z. So at position X, it will have a, because it's far, so it will have a high gravitational potential energy maximum and kinetic will be minimum. But as it is moving, the GP start to decrease, not too much, but it start to decrease, and potential energy start to decrease and kinetic is increasing. And same thing from Y to Z as well, the potential, because here it will have a maximum kinetic energy and the potential energy will be minimum. So this point, because it is coming closer, how you identify all the position, like this, if you compare the distance from the sun, it is decreasing. So if a distance is decreasing throughout the motion from X to Y or Y to Z, the potential energy is decreasing. So if the potential energy is decreasing, the kinetic energy should increase. So both cases, from X to Y or from Y to Z, the GPE is changing into KE. So we have the two asteroids are there, the dwarf planets that orbit the sun. The orbits are not approximately circular. The sun gravitational field at the orbit of Ceres is weaker than of orbit of Vesta. How does the orbital speed and its orbital period compare with the orbital speed and orbital period of a Vesta? So how you identify, remember one thing, that those objects which are closer to the sun, if you remember the table about the planets, so those planets which are closer to us, like closer to the sun, they are taking shorter time and they're experiencing stronger gravity. And those planets which are far from the sun, they're experiencing weaker gravity. And when they're experiencing weaker gravity, they're taking, and their paths are, because longer path is there, so they will take longer time to move. So here, first you have to identify these positions. So Ceres will be here and Vesta will be far. Why? How I identify that? Because they mentioned the orbits are approximately circular, but the gravitational field strength on the orbit of Ceres is weaker. Sorry, it's weaker. So Vesta will be closer. Vesta will be closer, and this should be away because it's weaker. Now, and they are both circular. Both are circular, as you can see. So first, orbital period. Orbital period, the one which is closer, The one which is closer will take a short time. So, and the one which is far will take a longer time. So this will take, the one which is closer, this will take short, and this will take longer time. So orbital period of, when we compare, the vista will take a shorter time. So this will be, the vista will, this series will be greater than vista. So either B can be an answer or D can be an answer. Like two options are there. Orbital period and orbital duration is the same thing. There's no difference between them. The orbital duration and the orbital periods are the same thing. And when we talk about the orbital speeds, like we have this table, which is important, like you remember the comparison. See, this is the orbital distance as a, and this is the orbital duration. So for orbital duration, as we move away, the orbital duration is what is happening to the orbital duration. It is increasing. Like if the objects are far from the sun, they will take much longer time than objects which are closer. And when we compare, so the first part is the duration. So we have sun is there, like this is representing the sun. And the orbit of approximately circular are there, and the gravitational field strength or gravity of the sun at series is weaker than of vista. So it means this will be vista, this will be series. And we have to compare how does the orbital speed and the orbital period compare. So first remember about the orbital period, the one which is far will take longer time. So orbital period of a series will be more than the vista. So that's why we say either B can be an answer or D can be an answer. But what about the orbital speeds? So then orbital speed of us, when we talk about the, because the same idea is that the orbit, it's taking, because it is taking longer time. So if it is taking longer time, it means it is moving slower. And you can also understand from one thing, how you can understand, like when you compare the potential energies of Vista with series. So Vista will have a smaller potential energy, so more kinetic energy, because it's closer to the sun. So potential energy is lower, so kinetic energy will be higher, so it will move faster. But for series, what happened? Because it is far from the sun, so potential energy is higher, so its kinetic energy will be lower. As a result, it will move slower. So this will move slower and this will move faster. That's why the orbital speed of a series is smaller than of Vista. So B will be the right answer. Is it clear, this one? Anyone having a doubt in this? In question 5, sun emits energy in the form of electromagnetic radiation. What are the three components? As you can see, when we discuss about the key points, we discussed that sun is emitting out infrared radiation. It is emitting out the ultraviolet, and it is also emitting out visible. That's why C is the right answer. It's not emitting out micro. It's UV is there, visible is there, and infra. When in the life cycle of a star, a heavy element produced. Microwaves are produced when a temperature is very low. See, cosmic microwave background radiation are different because cosmic microwave background radiations are emitted when temperature is too low. So in this question, when in the life cycle of a star, a heavy elements produced. So what case heavy elements are produced in a life cycle of the star? When we check the options, when a cloud contain hydrogen collapse, no, that's it's basically hydrogen fusion happen. When a protostar becomes stable, again a hydrogen fusion is happening. When a red giant, so what actually we have when we have a red giant and a red giant is like exploded. So that case, because what happened, first we have a hydrogen fusion in a main sequence star, then we have a red giant is there, which is a helium fusion. And then when a helium fusion stop, the star collapse, the temperature increases. This result in a formation of the heavy elements or in a supernova it produce. When a cloud containing hydrogen collapse, the element it only produces helium. When a protostar becomes stable, it also produces helium. But here what happened when a red giant explode, the helium produced like the other elements are there, carbon, nitrogen, these elements are there. A is a protostar, like it's like a molecular cloud to a protostar. It's turning from a molecular cloud to a protostar. And a white dwarf is formed. Formation of a white dwarf is not forming any kind of elements, new elements, because it's just like a death of the main sequence star, which is having mass same as the mass of a sun. So we have question 7. In question 7, we have J, K, L, and M describes as a different stages. What is the order of first to a light with a stage occur for a smaller star? So first we have a smaller star. So it will be a protostar. Then from a protostar, it will be a main sequence. Then from a main sequence star, it will be a red giant. And from a red giant, a supernova leads to a formation of a white dwarf. Not supernova, planetary nebula. Sorry, by mistake, I said supernova. So white dwarf will be there. So this will be the stage of the star. So first, we will have a protostar. So which one is a protostar? A cloud of a hydrogen collapse due to gravitation. This is a protostar. Like this is J, a protostar is there. Then a hydrogen undergo fusion to produce helium. So means this turned into a main sequence star. Because when they are coming closer, that is like a protostar. And then when they start a hydrogen fusion and balances, that is a main sequence. Yeah, hydrogen fusion means helium will form. Hydrogen fusion, nuclear fusion produce helium. That's happen in a main sequence. And then a red giant is produced. So this will be a red giant. And then a white dwarf is produced. So L. So what is the sequence? JMKL. JMKL. So that is option A. Is it clear? This one? The next, what provide evidence for a Big Bang? So what is providing the evidence for the Big Bang? When we check the expulsion of a heavy elements into a space during supernova, like when heavy elements are spread out in the due to the supernova, this is not evidence of a Big Bang. Increase in observed wavelength of a radiation, like when we observe the radiation from the distant galaxies, like galaxies far from us, we observe the wavelength which we receive has increased, like they're giving us a redshift. So this is an evidence of a Big Bang, because like if they're giving us a redshift, means they're moving away from us, and as they're moving away from us, it shows that the universe is expanding, or as the universe is expanding, so it is started with a Big Bang. A nuclear fusion reaction takes place at the center of a stable star. That is not evidence of a Big Bang. A smaller orbital speed of a planet that are further from the sun. So planets which are far from sun are moving slower. That is not giving any evidence of a Big Bang. It shows the relation of a gravity with the orbital distance, but not a Big Bang. Is it clear? Question 8. So this was, I think, how many, any others? This was, yeah, okay, structure questions are also there. Five structure questions, okay. I'll share another link and discuss the structure questions. Join from that. The reason is that otherwise, if I start discussion in between, the session will end. So I'll share another link with you.